Hello everyone, in this video we are going to be looking at how to solve systems of equations by graphing. Alright, this helps us visualize what we're doing when we are solving systems, when we're solving multiple equations at the same time. Okay, so in example A, we've got this system, these two equations that we are trying to solve at the same time. So I'm going to graph both equations. So this one's going to be line 1. I'm going to make blue. So if I graph this, I'm going to start at -4. And I'm going to go up 2 to the right one, up 2 to the right one, so on and so forth. I'm going to zoom in just so I can make this a nice straight line. All right, so there we got line 1. Let me get line 2. Y equals -1/3 x plus 3. So I'm going to start at +3. And I'm going to go down 1 to the right 3. And there you'll notice is our point of intersection. All right, where we hit the first line. So this right here is the point of intersection, which is my solution. So the solution here is 1, 2, 3, 2. The coordinate 3, 2. So that is the solution to my system. That's the intersection point. That's where these two lines intersect. And I can check this. I can check this by plugging them into both equations. So let me get my blue out. So for the first line, I plug in 2 for y and 3 for x. And I simplify. So 2 times 3 is 6. 6 minus 4 is 2. So we get 2 equals 2. So it works for the first line. Let's check it for the second. We got y equals -1/3 x plus 3. Plug in 2 for y. Plug in 3 for x. -1/3 times 3. That's going to give me -1. -1 plus 3 is 2. So 2 equals 2. It works for both equations. All right, so a system of equations, 2 or more equations that we're trying to solve for at the same time, the solution is the intersection point, which has to work for both equations when I plug it back in. So that's how we check. So in B, before I can graph this, I got to get them into slope-intercept form. So 4x plus y equals 8. That's the same thing as y equals -4x plus 8. Subtract 4x from both sides. And then, let's see, we'll do green for this second one. 2x minus 3y equals 18. Subtract 2x from both sides. So I'll get -3y equals -2x plus 18. Divide everything by -3, so I get y equals 2/3 x minus 6. So now that my equations are in slope-intercept form, I can graph them. So going back to line 1, my red line, start at 8. Go down 4 to the right one. Down 4 to the right one. Down 4 to the right one. Connect the dots. That line's a little off. Let me try again. Helps if I zoom in a little bit. That's better. Okay. And then for my second line, y equals 2/3 x minus 6. Start at -6. Go up 2 to the right 3. There you'll see is our point of intersection. So I'm going to stop there. Highlight this point because that's my solution. So the solution is 1, 2, 3, 1, 2, 3, -4. 3, -4. All right, now let's test it. We can test it either in the original equation that we were given or in the slope-intercept form that we transformed it into. Because remember, those represent the same line. So if I check it in the first equation, so 4, and then I'm going to plug in 3 for x, plus, and then I'm going to plug in -4 for y, equals 8. That's going to give me 12 minus 4, which equals 8. 8 equals 8, so it works for the first one. For the second one, I'll use the slope-intercept form version. Again, doesn't matter. Oops. But instead of y, I'm going to plug in -4. I got 2/3. Instead of x, I'm going to plug in 3 minus 6. 2/3 times 3 is 2. 2 minus 6 is -4. So you get -4 equals -4. Left-hand side equals the right-hand side. Therefore, this solution works for both equations. Therefore, it's the solution to the entire system. All right, let's do 2 more examples. Let's transform this first one into slope-intercept form. I subtract both sides by 4x, divide everything by -3, and then I'll get y equals 4/3 x minus 8/3. Okay, so 4/3 x minus 8/3. And then for the second equation, subtract 8x, divide by -6. So I'll get -8 over -6x minus 16 over 6. If I simplify this second line, you'll notice it's 4/3 x minus 8/3. All right, so if I were to graph this, -8/3, that's -2.6 repeating. All right, so if I try to graph this first line, -2.6 repeating, my y-intercept is going to be about there. And I'm going up 4, 1, 2, 3, 4, to the right 3. So it'll be about there. 1, 2, 3, 4, 1, 2, 3. So that would be my line for the first one. But notice, the second equation is the same exact thing. Y equals 4/3 x minus 8/3. So I'm going to start here, go up 4 to the right 3, up 4 to the right 3. Notice it's the same exact line. Okay? This is the same exact line. Okay? All I would have to do, if you notice back in when they're in standard form, if I just multiply the top equation by 2, I get the bottom equation. They're the same exact line. So whatever works for the first one, whatever I plug in for x and y in the first one, will work if I plug it in for x and y in the second one. So this is infinitely many solutions. Okay? Whatever I plug in for x and y for the first is going to work for the second because they are the same exact line. All right? So that is a type of situation. That's a weird one, right? They intersect forever. What about in part D? We got 2x plus y equals 4. So if I solve this for y, if I get this into slope-intercept form, I get y equals -2x plus 4. What about my second equation? I get y equals -2x plus 1. So if I were to graph these, first one I would start at 4, and I would go down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1. I get something that looks like that. For the second line, I start at 1, and I go down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1. Okay, what do we notice about this graph? Okay, these graphs will never intersect because they are parallel lines. They have the same slope, but different y-intercepts. So these are parallel lines. All right, will parallel lines ever intersect? No. Therefore, will this system ever have a solution? No, they will never intersect. So this is no solution. So if you remember, parallel lines means they never intersect. Okay, so that's another type of weird one compared to part A and part B. All right, these two lines are never going to intersect. All right, that leads us into a discussion of what different types of systems can we have. All right, we could have a consistent, it's called a consistent system, and that has a solution. All right, independent means it has one solution, which means we have two lines that intersect once. Okay, that would be an independent, consistent solution. All right, we could have a dependent solution, which is two lines that intersect all the time. All right, so this would be infinitely many solutions. Infinitely many solutions. And that happens when they're the same line. Okay, it's dependent. That would be a dependent consistent solution or system. So that would be happening if they're the same exact line. And then last but not least, we have an inconsistent system. All right, and that has no solutions. That would happen if we had parallel lines. No solution, no intersection point. Okay? So, a system of equations, in order to find the solution, we're trying to figure out where the two lines intersect. So let's go back and classify each of these systems that we started with. Let me just make this big. All right, so for the first one, it has a solution, only one solution. So that would be consistent, independent. Okay, same thing with part B. One solution, one point of intersection, consistent, independent. All right, in part C, those are the same exact lines, so they have infinitely many solutions. So this would be consistent and dependent. And then in part D, I have two parallel lines. They will never intersect, therefore there's no solution. So this is an inconsistent system. All right, so in future videos, we will talk about how to solve these algebraically, because we're not always going to want to graph them, and our solutions aren't always going to be nice. All right, so, but to start this unit, to start this idea of systems of equations, we want to look at graphing. Therefore, we can visualize and conceptualize what a system is and what that solution to that system represents. The solution represents the intersection point. If you have any questions, let me know. Make sure you start your practice.